Hello students, in the last class we have already solved exercise 4 of chapter number 1 and first question of question number 7. Now let us move further. We will solve now question number 2 of the same question number 7. Okay, question number 2. We have to find the domain of the function. Find the domain of the function f of x is equal to square root of x minus 1 plus square root of 6 minus x. Obviously, for the given function f of x is equal to square root of x minus 1 plus square root of 6 minus x, we must have both x minus 1 greater than or equal to 0 and 6 minus x greater than or equal to 0. Therefore, x greater than or equal to 0 and x minus 6 less than or equal to 0. Sorry, here x greater than or equal to 1. Okay, therefore x greater than or equal to 1 and here x less than or equal to 6. Now if you combine both these in equations you will get, so let us number them 1 and 2. So from 1 and 2 we can write that x lies between 1 and 6. So 1 less than or equal to x and x is less than or equal to 6. This is the domain of the function f. Okay, now the next question, that is question number 3 in 7. Okay, question number 3, we have to find the values of theta for which the function f of theta is equal to sin theta upon cos theta minus sin theta is not defined. Now we know very well that this function f of theta will not be defined if the denominator is equal to 0. So function f of theta is not defined if cos theta minus sin theta is equal to 0. If the denominator is 0, then the function is not defined. Let us simplify this equation. Therefore cos theta is equal to sin theta. Therefore 1 is equal to tan theta. Therefore tan theta is equal to 1. And therefore theta general value will be n pi plus pi by 4. So for all theta equal to n pi plus pi by 4, the function f of theta is not defined. Please note down. Okay, now let us solve the fourth question of seventh question, fourth sub question. The function, this is 7th, number 4. Okay, function f of x is defined by 1 upon square root of modulus of x minus x. Okay, we have to find the domain of this function. We have to find the domain. Okay, now we know that this square root will be defined only if modulus of x minus x will be greater than 0. Okay, so since this part is in denominator, so denominator must not be equal to 0. So f is defined if modulus of x minus x is greater than 0. Okay, now say this is number 1. Now if modulus of x is equal to x, then x minus x will be equal to 0, and therefore f is not defined for x greater than 0. Clear? Because if x will be greater than 0, then only modulus of x will be equal to x. Okay, now if, or we will write, if x is less than 0, then modulus of x will be equal to minus x, and therefore modulus of x minus x equal to minus x will be equal to minus 2x, which is greater than 0. Why? Since x is less than 0. So x is negative and minus 2 is negative, so minus minus plus, therefore this value will be greater than 0. So obviously from this we come to know that x must be less than 0, and therefore domain of function f equal to from minus infinity to 0. This is the domain for the given function f. Please note down. Okay, now question number 8. For question number 8 now. Okay, f of x is given to be 2x square minus 5x plus 2. Okay, we have to find the value of f of 4 plus h minus f of 4 upon h. Okay, so in order to find this value, let us first find out f of 4 plus h, then f of 4, and then we will put the values in this expression. So f of 4 plus h will be equal to 2 into, for h we will substitute 4 plus h. So 4 plus h the whole square minus 5 into 4 plus h plus 2 is equals to 2 into 16 plus h square plus 8h minus 20 minus 5h plus 2. On simplification we will get 2h square. Okay, 2s are 16 minus 5 plus 11h and 32 minus 20, 34. Okay, 16 2s are 32 plus 2, 34. So 14 is left. Clear? So this is f of 4 plus h. Now let us calculate f of 4. substitute for x 4. So 2 into 4 square minus 5 into 4 plus 2 is equal to 16 to the 32 minus 20 plus 2. So again 14. F of 4 is 14. Now let us put these both the values in the expression. Now we have to calculate f of 4 plus h minus f of 4 upon h. F of 4 plus h is 2h square plus 11h plus 14 minus 14 upon h. Let us simplify. 14 will get cancelled. From these two terms take h common. So h will be common. 2h plus 11 is left inside the bracket. H will get cancelled. So 2h plus 11 is the answer. Please note down. Okay, question number 9 is checking whether the given function f of x and g of x, two functions are given, even or odd. That you can check, or let us do this on the board only. Question number 9. Okay, function f of x is given to be x plus 3x cube and g of x is given to be 3 minus x square. We have to check whether these are even or odd. Okay, first let us take f of x. Function f of x is equal to x plus 3x cube. We will find out f of minus x plus 3 into minus x cube is equal to minus x minus 3x cube equal to, take minus common, x plus 3x cube equal to minus of f of x. So finally we got f of minus x is equal to minus of f of x, and therefore f is odd. We have seen this definition earlier, what is even and what is an odd function. Now let us take g of x. So function g of x is 3 minus x square. Okay, we will find out g of minus x is equals to 3 minus x the whole square is equals to 3 minus x square is equal to g of x only, and therefore here we got g of minus x is equal to g of x, and therefore function g is an even function. Please note down. Okay, 10th one is a simple one leaving for you. Function f of x is given. You have to prove, as we have done in question number 8. It is almost similar to that only. Second part of question number 10 we will solve. Okay, question number 10. question. Here two functions f of x and g of x are given. We have to check. The question is like this: are f of x is equal to g of x always, is f of x equal to g of x always? This statement is true or not, that we will discuss. Obviously, let us discuss the domains of the two functions. We know that the domain of f of x is R. What is R? Set of real numbers. Okay, while the domain of g of x is equal to x square upon x. Now it is very evident that this function is not defined at x is equal to 0. So the domain of g of x is r minus 0. Since the domain of both the functions are different, therefore these two functions will not be equal. Okay, so when they will be equal, therefore f of x is not equal to g of x always when x is not equal to 0. In that case, g of x is equal to x square by x is equal to x only, and therefore f of x will be equal to g of x. So these two functions are equal only when x is not equal to 0. Clear? So this is the answer. These are the answers. In the domain at r is equal to 0, the functions are not equal, but when x is not equal to 0, f of x and g of x are equal. Please note down this. Okay, now question number 11, the first one of question number 11. Okay, function f from r to r is given, and function f of x is defined by x square upon 1 plus x square. Okay, and we have to find the range of this function. So let us find out the range of the function. Okay, for finding the range, let f of x is equal to y, and therefore x square upon 1 plus x square is equal to y. Therefore x square is equal to y plus y x square. Therefore x square minus y x square is equal to y. Take x common, x square common, so x square into 1 minus y equal to y, and therefore x square is equal to y upon 1 minus y, and therefore x is equal to plus or minus square root of y 1 minus y. Okay, now okay, Now this function is defined only if we know that y upon 1 minus y is greater than or equal to 0 and 1 minus y is not equal to 0, and therefore okay therefore again therefore we can write y upon y minus 1 is less than 0 since y is not equal to 1. Clear? Okay, because for 0 again this will be meaningless, so less than 0 since y is not equal to 1, and therefore now critical point, if you equate to 0, y is equal to 0 and y is equals to 1 we will get, and therefore by method of intervals you will get the range of y, that is between 0 and 1, and therefore the range of this function is equal to 0 to, in open interval, 0 to 1. Please note down. Okay, make a note that here it is greater than or equal to, so here we'll put less than or equal to 0, and y is not equal to 1, so here we will put yes. Now this is the name, because 0 is valid. Yes or no? You can take the value of 0, because for 0 this is not undefined. Clear? Please note down. Okay, now question number 12. Let us solve this by discussion only. Function f of x is given to be x square plus 3x plus 5 upon x square minus 5x plus 4. Okay, it is defined at x is equal to 1 and 4. Undefined at x is equal to 1 and 4. So it is very clear that if you put here x is equal to 1, if x is equal to 1 you put, then 1 square minus 5 into 1 plus 4, 1 minus 5 plus 4 will be equal to 0. So denominator will be 0, then function is obviously undefined. Similarly, when you put x is equal to 4, again 4 square minus 5 into 4 plus 4, 16 minus 20 plus 4 is equal to 0. So when you take x is equals to 1 and x is equal to 4, in both these cases the denominator will be 0, and therefore function f of x will not be defined, and therefore f is undefined at x is equal to 1 and 4. Okay, similarly, another function, say g of x is equal to sin x upon x is given. It is very clear that if you take x is equal to 0, okay, g will be undefined. G of x is undefined at x is equal to 0, because if you put x is equal to 0, g of x becomes meaningless. Clear? Let us solve the next question. Okay, question number 13. Function f of x is given log x for x greater than 0. Okay, we have to show that f of p plus f of q plus f of r is equals to f of p q r. Okay, let us take function f of x is given log x. Let us find out f of p plus f of q plus f of r. This is LHS. Okay, f of p will be log p, f of q will be log q, and f of r will be log r, and log a plus log b plus log c is equals to log ABC, or here log p plus log q plus log r is equals to log p q r, since log a plus log b plus log c is equals to log ABC. This is product law. Okay, it is known, and which is equal to RHS. So here is the answer. Please note down. Okay, now question number 15. You are given y is equal to g of x is equals to ax plus b upon cx minus a. We have to prove that g of y is equal to x. Okay, let us prove this. Okay, we are given g of x is equal to ax plus b upon cx minus a. Okay, now we have to find out g of y. Okay, g of y, so in place of x we will put y, a into y plus b upon c into y minus a. Now the value of y, g of x and y are equal, so for instead of y we will put this expression ax plus b upon cx minus a. So let us substitute a into ax plus b upon cx minus a plus b upon c into ax plus b upon cx minus a minus a. Now let us simplify. You will get a square x plus ab plus bc into x minus ab. Similarly, denominator will be ac into x plus bc minus ac into x plus a square. Okay, so ab plus minus will get cancelled, acx will get cancelled. We are left with, here I will write down, a square x plus bcx upon a square plus bc. If you take x common from the numerator, a square plus bc is left and we have in the denominator a square plus bc. So on simplifying you will get x, and therefore you can say that g of y is equal to x. Clear? Please note down. Okay, now the next question, question number 16, first one. Question number 16. Number 1, f of x is equal to x minus 1 upon x plus 1. We have to prove that f of x minus f of y upon 1 plus f of x into f of y is equal to x minus y upon 1 plus xy. Okay, f of x, let us take LHS. F of x minus f of y upon 1 plus f of x into f of y. Let us put the values. F of x is x minus 1 upon x plus 1 and f of y is y minus 1 upon y plus 1. Similarly here, x minus 1 upon x plus 1 into y minus 1 upon y plus 1. On simplification we will get x minus 1 into y plus 1 minus x plus 1 into y minus 1 upon x plus 1 into y plus 1 plus x minus 1 into y minus 1. On further simplification, xy plus x minus y minus 1 minus xy plus x minus y and minus minus plus 1. In the denominator we will get xy plus x plus y plus 1 plus xy minus x minus y plus 1. So like terms with opposite signs, let us cancel them. Okay, so denominator is left with x plus x, 2x minus 2y, and over here x and y will get cancelled. So 1 plus 1 2 plus 2xy On taking 2 common from both numerator and denominator, we will get x minus y upon 1 plus xy, which is equal to right hand side. Please note down. Okay, further questions we will solve in the next video. Please note down this question. Thank you.